All right, thank you everybody for coming to, what did I call this thing? OpenStack Basics. It's for the absolute beginner. When I say absolute beginner, obviously if this is your first day in IT, this might be still a little difficult for you, but some assumptions, you have to kind of know what Linux is, or you have to have some basic knowledge. But beyond that, we're starting at the beginning. So if this is your first summit, if it's not your first summit, if you were just given this to do, this will be perfect for you. This is a picture of me with a bunch of words that talk about me and what I've done. Long story short, built a cloud at American Express, a very big one, back in 2013, 2014. And then from there, I went off to Mirantis to help them build their distribution and do a lot of architectures for Fortune 100s. And now I've written a few books and done some other things. How I got started in OpenStack, I think, is important. I was at American Express, coming off a $1 billion project, and was looking for something else to do. And I had an executive sponsor come up to me and said, "Hey, your next project is going to be building an OpenStack cloud. We're going to be moving everything off of our legacy platform into this, and it's time to get started. So let's go." Luckily, I had about 3 weeks until I started the next phase. Had to start this OpenStack project. So I thought, no problem. I'll do like everybody else does, right? We'll get on Google. I'll have this thing licked in a week, right? I'll learn how to install OpenStack. I mean, they give you a CD, don't they? They just put it in, and then you press go, and it gets installed, and then there's a big manual that tells you how to do everything, and we'd be cool. So I got on Google, and after 3 weeks, I look like that. I was very surprised back in 2013 or 2014 that, there were videos. There were videos that talked about Oslo messaging and how how to configure it, and how to install OpenStack by hand, and this project's the greatest, and this project will do this and do that, and has interoperability with this and that, and I didn't even know what a project was. I had no idea. Shortly afterwards, a couple months later, I was sent off to one of the summits. And when I got there, as some of you have found out if you've gone to other summits, that the beginners tracks are a little wanting, in my opinion. There's things for beginners, but it's more walkthroughs on installs and things like that. They don't talk about the what and the why and how did we even get to where we are. So why cloud? Why did it start? Weren't we just happy with our appliance-based or our hardware-based servers? Like we go get some HPs or Dells or something, and we put them in racks, and we hook them up, and we get operating systems on, and then other guys come in and put web servers or app servers on them or database servers, and then we run our apps, right? And that's cool. And if we want more, we just order more servers and we put them in racks. And for some of you, I'm sure you see you smiling. That's like, that's really how we used to do it. Believe it or not. And it wasn't that long ago. So, we're talking like Web 2.0 days, where, we have applications, web scale applications running, and then maybe we might hook into other APIs for services to pull in WordPress or pull in other different third-party applications to work with our static web pages. That's kind of Web 2.0. But the problem with Web 2.0 is scalability was a problem. Efficiency was a problem, How do you get these new servers you're going to rack? And what happens at Christmas? Or what happens if you have a product launch and there's a whole bunch of demand? Well, for the most part, it wasn't a major problem, because the way we did scaling back then was, let's make sure our hardware-based systems, they run at 10% of capacity during off-peak. That's real efficient. So 90% sitting idle, and then during peak times, we're going to set up our monitorings. We hit 75%, you better page me, because that's scary. Oh no, we're at 75%. Then we hit 75% once. What do? We go to our provisioning system, we order more servers. But we have to get approvals first. And then we have to find out budget. And then somebody has to build them, and then they get them sent in, and then they got to put on a truck, and then you put on a hand cart, and then someone screws them in, and they don't have enough screws, you got to wait, and then they cable them, but there's not enough colored cables. They switch them around. 55 days later, I have a new server. Meanwhile, now all of my servers are at 75% or 99% or whatever it is, and we've got a problem. Not efficient, not scalable. So, and again, as I said, there's a bunch of approval workflows that could be sitting on people's desks for forever. So let's go here. So by 2006, Amazon had this problem. Amazon said, this is ridiculous. Why are we doing this? There's got to be a better way. So what they did is they looked at their systems and they found out that, again, they were only using 10% of their capacity during off-peak and at most 40 to 60% during on-peak. That's a lot of wasted systems. So they wanted an easy self-service way to provision what they had and to get it into the hands of developers and users so that they didn't have to order new machines. So they started AWS, and AWS was an internal project so that they could have an internal cloud to build their retail services on. A few years earlier, there was a company named Salesforce.com in 2000 or 1999. They created a service where they built it so that you could have software as a service. So all the applications didn't reside on users' servers. They resided on a web page where you can go, or on a website you can go and give yourself, serve yourself applications. So at that point, they were working on this solution, and they couldn't really figure out how to do it in the current construct. So, as I said earlier, the challenges were hardware-based or virtualized environments, and it was really a challenge for them to grow, especially at the rate that someone like Amazon was growing. So in 2006, as I said, they came up with AWS. They were facing these kind of issues of scale because they were AWS. Most of the companies today, or even back then, they weren't feeling that type of scale problem. They weren't growing as fast as Amazon. So most other companies were laggards. However, eventually it caught up. So we talked about cloud computing, them starting a cloud, and I think this is a very important part of the equation, that the value of cloud computing is in the outcomes it enables. As I said, if you're an app team in a company, back in the pre-cloud days, what would you do if you had an idea for a new app? You would first tell your boss. Your boss would say, great idea. Nobody else has it. Let's get strategic advantage. Let's get you working on it. Okay, well, I need something to work on. I need hardware. Okay, hold on, let me check my budget. He checks his budget. Okay, I've got budget. Go ahead and order it. When's it going to arrive? 3 weeks. Okay, I'm going to do my local code. I have nowhere to test it. All right, so it comes in and they start testing it and on their local systems. They get it all hooked up, and then they need someone to install the OS. That's another team. And then themselves, or they hire someone else to install the web and app and DB parts of it. By the time it's all done, as I said, we're 2 months into this. Guess where their strategic advantage went? It went away about 5 weeks ago. Somebody else, who had spare hardware, got their idea first. So the value of cloud computing is the outcomes it enables, and the outcomes that it enables is it's kind of like similar to the value of an elliptical trainer, right? So I like to call this as weight loss as a service. And you get on a elliptical trainer, and so it's like you plug in the elliptical trainer API, and you do your workout, and what comes out the other side is less weight, calories burned. Same thing with in cloud computing, it avoids the problem of dev team ticket requests to the infrastructure team, to the infrastructure deployment, dev team adding tools, middleware, application. All of these things are possible for the self-service. And we'll see, the next slide here. What is cloud then? So if cloud computing is a self-service platform where you can get infrastructure quickly and scale it rapidly, what is this cloud we're talking about? First, we want to clear up what cloud is, right? So the best definition I heard, and this was sort of inspired by a Red Hat definition, was the clouds are pools of virtual resources like power, memory, network, storage, or applications orchestrated by management and automation software. And there's 4 different types. You'll hear that there's 3 different types, but I'm arguing with that there is not 3 different types. There's actually 4 now. Since the advent of private and public cloud, the first 3 came up very quickly. Public cloud, it's a shared resource, pay as you go. We know it as AWS or Google Cloud or Azure. Private cloud is a dedicated cloud to you where you get to control the resources. You don't pay as you go, but you have to make an initial capital investment. Hybrid cloud is a mix of private and public orchestrated together, whether it's private on-premise or private hosted. And then multi-cloud, and again, this is a very large distinction, is use of multiple cloud computing services in a single heterogeneous architecture. Meaning, hybrid cloud, you have your workloads spread across 2 clouds, but if you're using multiple clouds in your company to do an overall delivery of a service, that would be multi-cloud. They don't have to share a workload. So for example, with hybrid cloud, you may have your web servers in AWS and your app server and your database server on your private cloud, servicing requests in from CloudFront or something like that. Where multi-cloud is, you have your web app in DB for an app of one sort in AWS because you've decided it's closer to the consumer, needs fast access, and you don't have a database there. But another part of that app is another web app and database that runs in your private cloud and feeds data possibly into the multi-cloud architecture. So those are the differences that we see. Clouds and cloud technology, they aren't technologies unto themselves. They need operating systems, hypervisors, virtualization software, automation and management tools. Operating systems, they set up the network and host user interfaces. Virtualization abstracts the resources and then pulls them into clouds. And then automation automation software allocate the resources, and management tools provision new environments. So I think it's interesting. You ask somebody, what is cloud? And you will literally get, you ask 9 different people, you get 9 different answers. You ask 9 different companies, you get 9 different answers. But some of them have common threads. And just to prove this point, I'm going to read some definitions from some major companies in the OpenStack and cloud arena so you can see how everybody answers differently very shortly. Red Hat says clouds are pools of virtual resources such as raw processing power, storage, or cloud-based applications orchestrated by management and automation software so they can be accessed by users on demand through self-service portals supported by automatic scaling and dynamic resource allocation. Whew, thank you Red Hat for that. That's a mouthful. Amazon says cloud computing is the on-demand delivery of compute power, database storage applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. Oh, wait a minute. Amazon added something. You have to get to it through the internet, and it has pay-as-you-go. Well, Red Hat said nothing about that. Well, what does Microsoft say? Cloud computing is the delivery of computing services, servers, storage, databases, networking software, analytics, and more over the internet, the cloud. Companies offering these computing services are called cloud providers and typically charge for cloud computing services based on usage. Salesforce says cloud computing is a kind of outsourcing computer programs. Using cloud computing, users are able to access software and applications from wherever they need while it is being hosted by an outside party in the cloud. And Google, finally, says that cloud computing is a capital investment in building and maintaining data centers replaced by consuming IT resources as an elastic utility-like service from a cloud provider, including storage, computing, network, data processing, and analytics, and application development, machine learning, and even fully managed services. Okay, so the common thread, right? They want to talk about data, they want to talk about memory, storage, hypervisor, virtualization, providing it, getting to it by some means or another. So the the definition is fairly unclear. NIST, the National Institute of Standards and Technology, helped us out a little bit and set up kind of 4, I would say, guidelines for what cloud computing is. And they first call it, they first say on-demand self-service. So if it doesn't have on-demand self-service, if a user can't easily manage their own services without swivel chairing, like filling out a form and handing it to someone else and saying, hey, create me a VM, not a cloud. Broad network access, having access to virtualized or installed networks, accessible via the cloud platform. So if you have to call up a network group and say, hey, I need this VLAN run to my VM, not a cloud. Resource pooling, well, we talked about that, getting all the resources together and then giving slices of it out to other people. If you have to call someone and say, I need more CPUs, I need more physical CPUs, that is. I need more memory in my server. Yeah, not cloud at all. And then the fourth one is managing or having metering, so measuring how much you're using and able to show you in either a showback or chargeback model what you have. So this is, why cloud, just in summary. Again, efficiency, scalability. We can talk about cost a little later. Things like that, we're driving this type of development. What is cloud? These are the 4 types of clouds. We've talked about what is cloud and what is cloud computing, what everybody thinks it is, and what are the guidelines for it. And then these are the types of cloud services. So when we talked about outcomes as a service, right? Weight loss as a service on a treadmill or on an elliptical trainer, what you put in it, you put your body on it, it runs, what do you get out of it? You lose weight, heart health, whatever it is. Here's legacy. I think I have a pointer here. Here it is. Here's legacy IT. So here's what it says customer manage, but this is really what your IT group would manage, right? They manage everything. They would install your applications for you. They would do security, put the databases in, operating systems, virtualization. All of these things would be the responsibility of the IT team before they even gave it to you. Infrastructure as a service. Well, now we've eliminated some of these. So provider or this would be more the IT group here would be providing this. So they provide you with virtualization, the hardware to run it on, the storage to run it on, the networking to run it on, and they put it in a data center for you. But now, as a dev team or a customer of the IT group, this is what you're responsible for. So your responsibilities have shrunken. You don't need to know virtualization, server, storage, network, and data centers anymore. Just this in IaaS. Now, platform as a service, this is where you're delivered all of these things. So a real life example would be if you were a developer and you wanted a Red Hat Enterprise Linux 7.3 server running Tomcat, Apache, or some other LAMP stack or something like that, and you wanted it all configured, and all you wanted to do is install the jar file or just install the application or the Node.js application, whatever it is, this would be it here. So then you would have access to just deploy applications. And then software as a service, this is the Salesforce.com the example where you basically go to a website, or this would actually be like the Google Suite, Google Drive, Google Slides, Gmail, even Office 365. This is a type of software as a service. So these are the types of as a service we see now. So I want to just make sure that everybody kind of understands what a cloud is, what different types of services it provides, and how they're different. Each one of these topics we could go on for hours and hours and talk about, but we're going to kind of fly through them. We have a lot to cover. So here we go. Here's the meat, right? This is what you're all here for, to learn about AWS. I don't mean OpenStack, Right? Everybody's like, yeah, no, not AWS. What is OpenStack? So this I like this little picture. It's very, very simple. So OpenStack sits on top of a programmable network, compute resources, storage resources, and developers and admins go in through the APIs and provision and develop on it. The foundation says it lays a common set of APIs on top of compute, network, and storage, and it's one platform for virtual machines, containers, and bare metal. So with OpenStack, you can create virtual machines, you can create containers, or using one of the projects that we're not going to talk about today, but it's called Ironic. And the reason it's called Ironic is because we used to just do virtual machines, and then they came out with bare metal. And for a virtual machine platform, it was ironic that we would provision bare metal. But okay, high five for the name. But it can do all three of these now. So again, let's think back to Web 2.0 days, legacy days. You wanted to create virtual machines. What was the default, the de facto standard, right? VMware, right? We would go to VMware, we have VMs. Containers, well, I wouldn't say containers didn't exist because that would be a misnomer, but they were mostly living in Sun. So they were called containers there, or virtual hosts, or whatever you want to call them. And then bare metal, well, that was legacy. That's what we used to be doing, right? We would provision bare metal. How would we do that? We'd kickstart them, we would jumpstart them, we put CD-ROMs in, we would ghost them. Anybody remember Ghost? Yay, Ghost. All right, Windows boxes. Windows 95. But now, OpenStack is one platform, one orchestration platform that does it all, from soup to nuts. So why is it, OpenStack is open source, so why does that matter, right? We hear open source, open source, open source. All the time we hear open source. Gives you choice and control over your underlying infrastructure. You can switch vendors, you can add more vendors. If you think today of hyper-converged offerings, right? You have these hyper-converged offerings, they give you a box. Here you go, here's your hyper-converged. Well, what's in here? Never mind. Don't look under the hood. You know, it's all HP, don't worry about it. Or it's all Dell, or it's all Nutanix. Don't take the screws out, you'll void your warranty. So, I mean, that's the difference, right? Appliances or hardware-based, now you can control it because you're laying an orchestration layer on top of it. What runs underneath it, it doesn't matter. Developers will never ask you again, well, I can't promise that, but you can always tell them to go away now when they say, well, what's this VM running on? What does it matter? You got your vCPUs, right? But is it on Dell? Is it on HP? What does it matter? Yes. What if you have a hybrid setup? Yes, it's on all of that. Yes, it's all very good. Thank you, go away. Your ability to contribute. Never again, if it's open, do you have to say, man, I really wish I had this feature. I really wish I wish it had this button or this switch. Because if you can't find it and you can't influence someone else to write it, guess what you can do in OpenStack? You write it yourself. Write it yourself. Get it in your local, get into your local development environment, make sure it works. I always suggest people contribute back to the community, please. Please get involved and put a blueprint out for it and get it voted on and get it into the community. But no longer are there feature requests that go into the trash. Widely adopted open source APIs. REST APIs, I mean, who doesn't use REST APIs anymore, right? It's widely adopted, it's everywhere. And part of a vibrant community to share knowledge and help each other. Well, that's why we're here today. That's why I'm here, that's why all the other speakers are here. We're not paid, we come, we do this out of our belief that this is a great platform and that we want to help others. 4 OpenStack principles, you'll hear some about this if you go to other beginner sessions. Open source, well, that's kind of self-explanatory. If you don't know what open source is, see me after the lecture. Open design, as I said, if you come up with a great idea, you submit it into the community or into the group or the project that you're working on. We'll talk about projects later. And it gets voted on. And you vote yes, and your brother votes yes, and your cousin votes yes. I'm not suggesting you do that. No, that's wrong. But no, the community votes yes, and it gets approved. And guess what? Your patch gets accepted in. Your feature gets accepted in. But there's no real way to influence it because you're a cousin of somebody in the foundation. Does your feature go in first or get accepted over somebody else's? It's fully open. Open development. Again, you can go out and look at the source. It's being updated by the minute. There are people out here, if you walk along some of these rows, yes, some people are doing their email, some people are looking for shoes, but there are other people who are contributing code as we're speaking here. There are people doing patches, there are people doing all sorts of things, and it's updating the active OpenStack. Problems that come up, they're fixing them as we speak right in here. And then open community. All of our meetings are held in IRC or in public spaces. There's no closed door meetings. Think sunshine laws, think just fully open. There's not a secret handshake for OpenStack. At the developers conference, anybody can go, and you don't have to have a password to get in. They let anybody in. Primary business drivers. If your boss asks you why OpenStack, right? In the 2006 user survey, it was released in April, 2/3 of users says cost was their number one business driver, right? At American Express, where I used to work, that was the number one business driver. They were being killed by licensing costs from their legacy vendor of virtualization. I don't think I have to say the name, but every feature, every plugin, every new license, a new cost. OpenStack, the cost model is completely different, completely different. It's open source. You do what you want with it. Operational efficiency. Well, we talked about that. Spinning up new resources, spinning up new pooled resources, right? You got a whole bunch of pool of resources. You give a little here, give a little there. You keep some capacity and demand, keep it off to the side. Hey, it looks like we'll be able to forecast this because the pool goes like this constantly. People checking things in and checking it out, need some development, don't need it anymore. It goes like this. You're able to tell how much you need in plenty of time to order that hardware, get it put in, and guess what? There's no downtime. You just bolt it onto the side, keep bolting it on. You can do that with compute and with storage and with network. Accelerate innovation. Again, using infrastructure as code. And again, I don't have a session on that. It's more of a DevOps topic. But basically allowing developers to interact with these API services to create VMs as part of their deployment. So for example, I want to bring up a web server. Well, before, you had to get a machine, put the OS on it, log into the machine, install Apache, put the patch sets on, do all this type of stuff. But using OpenStack and using the APIs, you can have one command that says, do all of this. Put it all in. Make me a VM. So when you're running a testing procedure, like user acceptance testing, that's the first line. Create my infrastructure, run all the tests, run all the load tests. If it blows up, crush the thing up, put it away, give me an alarm. If it's successful, show me the performance parameters, then crush it up and put it away. So it helps accelerate innovation. Nobody has to wait for infrastructure anymore. You do it yourself. You're given resources. What runs on OpenStack? I'm not going to read all these out to you, but everything. Everything runs on OpenStack. Mainframes don't run on OpenStack, just to let you know. Okay, that's one thing that doesn't run on OpenStack. But pretty much all the different use cases are here. You can see some of these that use it. Some of the larger ones are Walmart and CERN. Over 200,000, I think they're over 220,000 physical cores of OpenStack. 220,000. So if you think of, dual core machines, you figure out how many machines are running on OpenStack. So if you ever hear anybody say that OpenStack doesn't scale, wrong. It scales just fine. So these are some great user stories. I suggest you go online to openstack.org and look these up. There's some wonderful stories. So where did OpenStack come from? Did it just spring up out of the desert? Did aliens deliver it to us as a package to fight the evil vendor lock-in aliens? No. It's close, though. NASA had it. And they were working on a way, of course, to virtualize their infrastructure. And they developed a product called Nebula. And it was basically the early version of the project called Nova. And Nova is the project inside of OpenStack that creates VMs, and we'll talk about that shortly. But at one point in that, Rackspace reached out to NASA and said, hey, we have this infrastructure provider service that we're working on the same thing. Would you like to hang out and have coffee and see if we can, become friends? And they said yes, and then the friendship has lasted ever since. And they developed OpenStack. 2 years later, the OpenStack Foundation was established, and pretty much it's been history since there. The marketplace opened up, which is it helps potential users navigate what was and continues to be like a rapidly growing ecosystem of vendors and products that run around OpenStack and in OpenStack. 2014, Juno was the first enterprise-grade OpenStack that was released, which people who had Kilo running enterprise would probably argue with that, but that's the first one that was seen as enterprise. But even today, half of the Fortune 100 runs some sort of OpenStack, is involved with OpenStack, has it running in production, or has it in dev QA. And today, it's one of the premier platforms for private cloud, for containers, VMs, and bare metal. So who are all these wackos that are working on this stuff, coming to these conferences, working on it? Well, there's over 70,000 foundation members in 185 countries, and now there's over 700 organizations, businesses and organizations that provide support to OpenStack. It's a very vibrant community, and it's actually it's not getting smaller, it's getting larger. How do they release OpenStack? You'll kind of hear, if you're new to OpenStack, this will be a shock to you kind of, but it's every 6 months a new version comes out. Now don't panic, nobody's saying you have to upgrade your OpenStack every 6 months. The OpenStack code is fully backwards compatible, and anything that's not, or anything that is will cause problems for upgrades is at least n-2, so two releases back. Right now we are on coming up on Queens. Right now Pike is the release. We're coming up on Queens. Will be released in February 2018, and in October it'll be Rocky. And you're saying, well, these are some strange names, right? Austin, Bexar, Cactus, Diablo, Essex, Folsom, Grizzly, Havana, Icehouse, Juno, Kilo, Liberty, Mitaka, Newton, Okada, Pike, Queens, Rocky. Yes! All the way from the beginning. Where do you get those names? Well, they are associated towns or locations near where the summits are being held. So apparently there's somewhere near here that's called Queens. I don't know. Yeah, there you go. Thank you. I knew a local would help me out. I should know that, but thank you. So that's how that's done. Now, I'm sorry. Oh yeah, it's also alphabetical, right? So that's another challenge. And being open, if you're a member of the foundation, they give you a list of like 9 trillion names, and you're supposed to vote on them. If you go back here, Newton, I did not vote for that. I voted for null. That would have been an awesome name for a version, null. Like dev null, like nothing. But then I think they thought, well, if you like run a command to find out what the version name was and it came back as null, it might mess things up. So good on them, right? The OpenStack framework. So I think people, a common misunderstanding that OpenStack is a single product, that it's Windows 95 or something you put in and you just install it. Like, let me go get me some OpenStack, or I'll run down to my electronics store and get that box of OpenStack and I'll install it. Well, that's just not it. Very modular, and it's a group of nearly 60 open source projects, but we don't need them all. It's completely extensible and modular. So which of the 60 that you need is based on what you're doing. Now, we saw the use cases of what everyone's doing with it, and each one of those use cases has an architectural baseline of the projects that they need. Some of those will be under sample configurations on openstack.org, but here we have the project navigator, and this is on openstack.org, and it tells you what the name of the projects are and what they do. And we'll be covering some of these very shortly. But these are some of the core projects. And we'll kind of go over the naming. But I just want to make it clear that OpenStack is not one thing. It's not, I'm going to install OpenStack. If someone says, I have OpenStack installed, what that means to me is they at least have the core services, which there are 6 of, and we'll talk about those. But I have no idea what other services they're running. I'd say, well, tell me what your architecture is. Tell me how it's laid out. Tell me what it does. And then I can kind of figure out how they're running it. But, you know, the OpenStack mission is to provide a platform that fits every model, everyone's use. And, you know, as I said, on the Foundation website, you can find sample configurations, and they have them by use case, and they have them by functionality. If you're familiar with AWS, I know I've been picking on AWS people. I love AWS, by the way. Yay, taking my AWS test at the end of the month for Architect. Yay, AWS. I see a lot of fans in here. All right, tough crowd. It must be Azure people here. Or Google Cloud, right. Or Rackspace. Who's for Rackspace? Oh, jeez. Tough crowd. All right, so if you know AWS, these are some of the kind of, it doesn't have complete feature parity, you know, EC2 and Nova, but you can kind of understand them. If you know the ones on the right, you can understand the ones on the left. And you notice I point out that that is not an actual AWS user. Anybody know who this guy is? That's right, for dummies, right, thank you. AWS, I'm just trying to say that the AWS people are not dummies. Now, Google and Microsoft might argue with me, but. OpenStack service overview. So, we're not talking about what runs on OpenStack. That's a whole different discussion. This is how OpenStack runs. So there's what we call the control plane, and then we have the workload plane or the user plane. I've heard it's a lot of different ways pronounced, but this is we're lifting back the covers, we're opening the hood, we're opening the kimono, if you will, and we're looking at what's under what's under OpenStack. Dashboard, right? We all understand what a dashboard is. It's Horizon. We log in. We got a website, got a bunch of clicky things, forms to fill in. That's how we get our infrastructure. That's how we make things happen. And then these other ones we will talk about: compute, block storage, networking, image service, object storage, and identity service. We'll talk about them a little more. All right. So Nova. We talked about Nova a little bit. Nova was how to get VMs, create them. It basically provides the configuration for the VM. So it takes all of the things that you put into the API, all of the different parameters. When you want a VM, it takes all of that, puts it into a configuration file or set of configuration files and into a database, and then launches the instance. That's as basic as I can get for Nova. Supports a lot of hypervisors, and is a REST API service. All of these will be REST API services. Cinder, why they call it Nova? I don't know. It was called Nebula, and then it was NASA, Nova. Nova is something in space terminology. My biggest guess. So when it comes to block storage, look no further than your friend Cinder here. Think Cinder block. This is how I remembered it in the beginning. Cinder block, block storage. Cinder handles everything from the first API requests to the volume attach request. So attaching the block storage to the VM that was created by Nova. So this is that guy, okay? Think of them as characters. I had the same challenge as everyone here. If you don't have these memorized or don't know what they are, the names are not like 1, 2, or like block storage service, like BSS, or like VM service, VMS, or whatever. You're just going to have to memorize what their names are. They won't change, though. They will all continue to say the same. Except for this one changed once before, but we won't talk about that. This used to be Quantum, but anyway. Neutron. This is the most complex one. This is one I had the largest trouble with when I started. It provides a software-defined networking piece. Neutron's the king of the networking stack, formerly known as Quantum, provides SDN functionality and instances, and is extensible through layer 2 plugins and third-party add-ons. I have no idea why it's called Neutron. If anyone can answer that, I'd love to know. But it always reminds me of like Jimmy Neutron. You know, I don't know if you have kids or anything. Like the guy's always trying to invent new stuff, like cooler ways to get places faster and route through here. And all right, that's the best I can do with the Neutron. You know, he was very smart and into inventing things. And Neutron, very slick, very awesome. When I started with OpenStack, did not exist. It was all Linux bridge. It was all physical bridging. It was called Nova Network. It's deprecated now. Hopefully, if you're getting started with OpenStack now, you will never have to deal with it. By the way, Neutron does have that functionality. It's called provider networks. You can still go through Linux bridge. Glance, image service. You glance at images. You know, when you're Google Images, you glance at them. You don't look at them, you glance at them. So without glance, there's no love for an instance because there's nothing to put on it. Nova cannot work without instances. There's something you got to put on there, whether it's RHEL, Ubuntu, Windows, CentOS, Scientific Unix, you name it, it can put it on there as long as it's in one of the supported formats, and RAW, QCOW2, ISO, VHD, VMDK, et cetera, et cetera. Swift. You know, it's the object storage platform or project, object storage. So it is the elder. It is the OpenStack elder. It's as old as Nova. Developed to store objects. It's commonly used to store glance images, glance image files. It's fully compatible with AWS's S3 service. If you ever hear anything talking about S3 or objects or object storage, this is your guy in OpenStack. Fully distributed, highly available. As I said, it's been around forever. This is like the old man. This is the daddy. Here's the gatekeeper. This guy here. Without Keystone, you're not going anywhere because you have to validate the Keystone before using any of the other services, including Horizon. It is the authorization, authentication engine for OpenStack natively. And you pass through, even if you're doing SAML assertions or using LDAP or ADS, all those things can be done through Keystone. But what Keystone does, and is most important, is it generates tokens. So, for example, you want to use a Nova. So say, I want to boot a VM. First thing it asks you is, do you have a token? No, I don't have a token. Well, you better go get a token. Username, password, here's your token. Well, now you have a token. So you keep your token. The token is stored in the database of OpenStack. Then you go over to Cinder and you say, I want to create a volume. Do you have a token? Well, yeah, I do. Here's my token. So creates the thing for you. 2 days later, you come back and you say to Neutron, I want to create a port or a network. Do you have a token? You say, yes, I do. And it says, sorry, your token's expired. Get a new token. So there's default expiration is 1 day, but you still need a token for everything. That was a poorly delivered joke. All right. Simple view of how OpenStack services work. They don't all exactly work like this, but this is a pretty good representation of how they work. In through the API, you can do create, read, update, delete of VMs, of volumes, of storage. Let's use the Cinder example here with volume. The API communicates to a message queue and puts it on the queue. I need a new volume. The scheduler takes from the RPC, so it takes via RPC from the message queue and says, hey, looks like somebody wants a new volume. What volume types do we have out? What storage do we have out here? Oh, they want, regular storage. They don't need high-speed storage. Whatever's part of the request. Oh, well, I'm going to put it on that NetApp over there. Okay, puts it back out. Here's the NetApp. Brings it down to the service function. Says, hey, now adds on. Hey, I want this on the NetApp. It's 1 gig. Puts it in here. Then at the service function, it says, okay, I see that NetApp out there. I'm going to put it over here. Writes out to the database where it's going, where it's going to be, and then pushes it through the driver for the NetApp, which is configurable in the OpenStack configuration files, and goes right into the provider. Storage is created, and then guess what? All the way back up, back through the driver to the API, puts it on the message queue, says, hey, I created it, it's done. Here's all the information about it. It comes back as an answer through the API. And if you know this, if you can remember this, that there's two stateful services, meaning, they need static storage. There's static services, message queue, which let's call it stateful as well. There are ways to make it not stateful, but we'll call it stateful. The two stateful services, and then you have stateless services that run in this fashion. You know how 90% of the services or projects in OpenStack work. That's it. So you can follow it step by step. You can even turn on debugging in the logs and follow the request. Step, 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 step. So here's the architecture for OpenStack today. Oh, no, that's not. That's Game of Thrones. But if we could draw it, this is what it would look like. You'd have Ironic over here at the Capitol, and then the Tyrells, they would be Cinder, and the Night's Watch. But if you do a search on Google, you will find something like this from Cactus and Bexar and some of the olden days, only when we had a few projects. Nobody has been brave enough to do all 60 projects and make one of these. So that's why I laugh and say, this is what it would look like. There's Jon Snow right there. All right. Real life example, remember I said Cinder volume creation. I'm not going to go through this 1 through 3, 4, 5, but you can look and see. User, Cinder API, messaging bus, out of the messaging bus, enter Cinder volume, and Cinder schedulers in there. But Cinder scheduler volume goes to the back end. Here it is right here. So 3, Cinder volume, 4 into the back end, out of the back end, 6, 7, back to the API, 9, back to the person. All right? It's not rocket science. People are like, OpenStack is so confusing. It's like so technical, dude. It's so hard to understand. No, if you understand this, you can probably, if you understand this and you know Python, you can go start developing today. So we talked about a few core projects. Here's the rest of them. And as I said, I could do a whole lecture. This would take me 4 hours to go through all of these. So, but people say, well, maybe somebody says, OpenStack only does this. Well, no, it does all of this. All of DNS service, data processing, Hadoop, clustering service, search, workflow. A lot of the stuff you see on AWS that is commonly used is here. Stuff you see on Google Cloud is commonly used is here. And then stuff that's not, like the Tacker. That's an NFV orchestration service. They don't have that in Google Cloud. They don't have that in Azure. These are things that people one day woke up, maybe after a hangover or something, and they said, it'd be a really great idea for a project, dude, because I'm dealing with this at work. I'm working at Verizon, AT&T, Telstra, Reliance, and we have all these VNFs that I can't keep track of. I don't know these virtual network functions. How do I orchestrate them? How do I get them to go from one to the next or launch them in the right order? Well, dude, I can write it in Puppet. I can bash script it out. Or you can write a project and get the thing done right. And that's what people did. And they just keep coming in. So I'll let you guys, I'm going to publish this deck afterwards. It'll be attached to wherever OpenStack attaches it this time. But you can take a picture of it. All right, so people say, well, all right, I'm going to download OpenStack tomorrow. I'm just going to totally do all this and download it. Okay, you can do that. And docs.openstack.org is your friend. They have install guides for all different operating systems. I'm a member of the docs team, so I'm going to give it a thumbs up. But I will tell you that going through the docs and installing it by hand, that's a one-time exercise, maybe twice. It's very, very process intensive. You will learn a lot about OpenStack. And if you make a mistake, you will learn even more about OpenStack. But I recommend if your company's asking you to do something that you look into a distribution. And these are the 3 distributions pretty much left today that are kind of OpenStack, open source distributions. Red Hat, SUSE, and Canonical's Ubuntu OpenStack. If you're talking to a company or you have a company that says, look, we're a small, medium business. We don't have the resources to manage OpenStack. We might have someone to install it. We have developers to publish on it, but we don't have the operations staff. We don't have anybody willing to take this on. Operations has said, no way. Well, first I would give their operations team some raspberries and tell them, no guts, no glory. But it's really not that different than managing Linux boxes. However, there are options, and these are companies that provide managed OpenStack. So they will come into your enterprise, install OpenStack for you, and manage it remotely. So all you do is use it. That's it. You just use it. There are differences between all of these, and I would suggest that you reach out to a company to help you kind of navigate those waters strategically. Onyx is one of those companies, by the way. I'm not plugging, but these all have nuances. But in general, this is something that is offered. So I've made it, and I've got some time for questions. So this is where you raise your hand. All right, we have somebody with a microphone. Go ahead, yell. I'll repeat your question until it gets to you. Oh, okay. This right here. I know I went through this fast, so feel free to ask any question you want.
Thank you for saving me from yelling. A short question. So we have a small team. I mean, it's a medium-sized company, but a small team that will be dedicated to OpenStack. And we are a small cloud provider, mostly using vCloud and some other things. And the question here is, can the small team reasonably quickly onboard and manage this? So we would start without the dev part, and then later on get on that as well.
Absolutely.
Do you think that that's achievable?
Absolutely. The misnomer is that you need this huge team of Python developers and everything else to run OpenStack. That's not true. You just need somebody willing to learn the OpenStack architecture and learn the tools to manage it like anything else. If you were putting VMware in or vRealize or anything, you would still need people to know that as well. So a couple guys that are dedicated to putting it in and running it can scale up to 10,000 instances easily. Not a problem. I've seen it. It's not a major task.
Okay. I come from a company who does Radius DHCP for telco deployments. We're doing normal traditional boxes. So now we have a bunch of telcos that are all coming back to us to move everything to an OpenStack environment. Okay. So, but as we talk to all of them, some say, I'm going to use Ubuntu, Juju to do all the deployments. Some people are saying, I'm going to use Ansible to do deployments. So from a vendor point of view of a product, how do you actually sell into all these people? Because it's like, I will need to develop every single possible way of controlling my software through all the different configuration engines.
I think you're speaking about deploying the workloads.
No, just to bring up the VM and how to interconnect, that kind of thing. Because all of them are starting, let's say I run Juju, means I do Juju deploy stack, right? And then I join relationships. Or use Ansible, which will run some playbooks. But now I have my own code, which will probably sit on either CentOS or Ubuntu-based OS. But I will need to deploy it into a customer environment, right? And because I'm not running a single stack, that means I don't own the stack like Huawei or Ericsson or somebody owns the entire thing and they have their own hundreds of solutions in their own stack. So I'm going to sit in the open environment stack in these telcos. So to bring out a VM, I either have to have a playbook to start up the VM, right? Or I have a Juju deployment. So which means as a vendor, I need to develop every single way of interfacing.
No, that's what the REST interfaces are for. So the APIs are what you would use to bring up your VMs in all of these different environments. The REST API is the same no matter if you use canonicals. Juju is just a interface. The charms are just a way to line things up when you're doing workloads, but that's a choice you make. But the API, it interfaces with the API. So there are Puppet tools, Ansible tools, Chef tools. There are all sorts of other tools that will allow you to interface with the API either graphically or through code to bring up workloads in OpenStack environments the same. Two summits ago, they had a whole line of OpenStack Foundation and vendors and everything, and they told them on your clouds and on your software, bring up these workloads, go now. And they all, at the same time, launched all these workloads, and I forget who came out first, second, third, whatever it was. It's irrelevant because of the hardware. But the point is, as far as interoperability, they all came up and they all worked, running the same commands, running the same tools, running all their own tools. So there is no one way. It's the way you choose, the way you want to do it.
Thank
Go
you.
ahead.
Does it work?
I can hear you.
I work for F5 and start picking up OpenStack stuff for the last month and a half.
Mm-hmm.
And I'm facing the problem, I need my local environment, so I started playing with Devstack.
Mm-hmm.
In particular, I need Mitaka version of it.
Okay.
So can you tell how closely Devstack follows the real application? And because
Yep.
I will be testing a lot with Ansible and deployments and all that stuff. And now I have 5 flavor of image for that.
Mm-hmm.
But I always need my local silo to play with.
Right. So if you've installed the Mitaka version of Devstack, you've installed basically what's out there in trunk, what's out there on the OpenStack website, the final version of Mitaka. So if you're using that today, then you're using the end of Mitaka. If you go out there now today and download Devstack, you're going to download the Pike version. But that's the production version. So Devstack is used by developers to code against if they're making project changes. So it's as far as compatibility or as far as interoperability with what is really out there, it's right on. It's exactly what's out there.
I've been having a lot of troubles with particularly network installation scripts. I think what you referred to as previous Linux bridging, I think it still tries to use a lot of Nova networking as
Yes.
opposed to Neutron.
So Nova
I
Network.
had to do a lot of, I don't even remember now, all the lines I changed in the installation scripts.
Yeah. Nova Network was deprecated in Mitaka. So after Mitaka, there was no more Nova Network.
Yeah.
You can't even it's not there anymore. You would use Neutron provider networks. Yeah. And if you look that up on Google, it'll tell you how to switch from the Nova network over into provider networks. It's actually much better. It's not using the lineage bridging.
Yeah, it's much better. The problem is my customer, they've got Mitaka.
Okay. Well, provider networks is available in Mitaka as well as Nova Network.
Okay.
So either way, but without knowing your problem, I can't
But
can't
my
troubleshoot
question
it.
is more general. How closely Devstack follows just...
So the Devstack that you can, like if you download Devstack right off the site right now,
Yeah.
Mitaka Devstack, it's exactly the Mitaka that was
the Git.
Yeah, there was an end of life for each one of the releases. So at the end of life of that release, that's where the Devstack is right now. It never went any further, and either did their version.
Okay.
So that's it. Go ahead. Sure.
Cinder, Swift, Lance is all in Russia giving a storage service.
Yeah. Okay. Cinder is for block storage. At the end, the question was Cinder, Swift, Glance. What's the difference between them? They're all storage, but what's the difference? Well, Cinder and Swift are storage. Cinder is block storage. Swift is object storage. And Glance is the image service. So it catalogs where all the images are for your Red Hat, your CentOS, whatever, things that you're going to load into a VM. It can point to Cinder or Swift. So, I'm sorry, Cinder or Swift. So they can be held in object storage or it can be held in block storage.
What do you exactly mean by object or
Block storage, block storage is storage that refers to the actual location on disk. So databases, file systems, things like that, they go in block storage. operating systems. Think operating systems. They go on block storage. Object storage is for images, video files, HTML files, actual file storage. You can't put an OS on object storage. You can't boot from object storage. It holds things, objects, and not block locations. That's probably the easiest way to describe it.
Swift actually works on Cinder?
No, Swift and Cinder are completely separate. So Swift, its storage is on either Ceph, which is a distributed storage platform, or it can be on a NetApp, or it can be on an EMC vMax. The backend storage is irrelevant. The way that you refer to it is different. So object storage, objects have addresses that you would just refer to the object. Block storage has a block location on the storage device.
Basically, they're all independent.
Yeah, they're independent. Yes, they're independent. Yes. Yep. Yep. Go ahead.
The glance, as you said, is it predefined or it is customizable, like how it is a template? VMware side, I guess it is the same concept of template and the glance, what is there in OpenStack. Is that correct?
Like, I'm sorry about the template. Is the template?
The VM template, is it the same concept what glance is in OpenStack?
Yes and no. So you create images. You create images that you can put in Glance that have layouts in a certain way, right? You can have them have your security fixes, or in your company, maybe you have certain required software that has to be in an image. You put that in there. But creating a VM and attaching networks and things to it, there's another service called Heat. And that's where you put in code to say, launch the VM with this image, attach this storage, attach this network, configure it this way, and then out the bottom of Heat comes a fully configured, it can even be used for platform as a service. Install the web server, install the app server, and at the end, you have exactly what you need. But that's the VM orchestration service, where Glance is just telling which image you would like to use. Mm-hmm. I'm sorry, the blueprint of, for example, yes, yep. Like CloudFormation in AWS, where you're putting together a bunch of different commands to get one output, a VM or a workload configured in one way, that's Heat. There's another one called Murano, which is similar, but that's really geared toward a PaaS platform, and it allows you to drag and drop. I want this image with Oracle and Tomcat, and and then go, and then it'll put it together for you. That's another project it's in those 60 projects. Anyone else? Go ahead.
I have a question about one of the slides you put up, the one you said, this.
Yeah.
There was a queue on the left.
Yes.
What's the relevance of the queue? Why do you need a queue?
So as far as the messaging queue, or as any messaging queue goes, when you request certain services from the different APIs, as you can imagine, I have 1,000 users on my OpenStack platform, right? At any one time, 200 could be requesting volume creations, deletes, grow, shrink, whatever. There is no internal buffering service on the services themselves, so that what would happen is all of those requests would come in at the same time and they would be backed up. So what the queuing agent, which is RabbitMQ, what it does is it takes requests and then feeds them based on first in, first out type of things like that. It holds it in queue so that it doesn't get backed up. It allows proper flow. It could be. Even with RabbitMQ in the early days, there was something called Cupid, which was the early RabbitMQ. If the timeouts were set too low, the requests would go in, and before they were even done creating like a 50 terabyte volume, it would time out. And then it would go back, the volume would be created, but it would send a message back and say, nope, didn't happen. And then the request would come back again and say, create it again, and it would start creating it again, and then it would fail, and then there are these problems. So what it does is it provides a buffer between the APIs and allows you to send status back and forth without having it real time. Just never a good idea to not have any cushion in there. That's why most applications use the queuing agents. Anyone else?
So, if I'm new to OpenStack and want to not stop learning, so what recommended path?
I would look at docs.openstack.org first. Look at the install docs, look at the operations docs. Then what I would do is I would learn these core projects. You've taken the first step, obviously, download Devstack. Get yourself OpenStack on your laptop. You can load all of OpenStack into one VM. You can have it running. You can even create instances. It's going to be slow as death. I'll be honest with you. If you have it in a little VM on your laptop, you can't expect much performance out of it. But you can have a fully operating OpenStack or OpenStacks. I've run 5 OpenStacks on my laptop on this MacBook here, just to show people that you can run OpenStack, multiple copies of it, and just start playing with it. That'd be the first thing. There are some great books out there. OpenStack for Architects is one. I know because I wrote it. But Learning OpenStack is another one. There's videos out there. There's a website called learningopenstack.org, I think it is, that you can go to. YouTube now is great, better than when I was in 2013 when there was nothing. So there's a lot of great things out there. Also, there are companies that provide training. There are companies like Onyx that will come and do beginners courses for you at your company, if it's something that you need. They do customized training as well. So if you say, well, we need SDN training, we need a lesson on Neutron, we need, things like that. There's always that option. But yeah, today the resources out there for learning OpenStack are fantastic on the internet. Any more? No, one more question. Go ahead.
So you mentioned OpenStack can scale really well on the Infra end. Because there's a lot of customers I deal with, they're still on VMware and there's very little developer resources in those customers. When it scales down, at what point would you say, this OpenStack is preferred over what they have VMware environment?
I would have to say, depending on their workloads. So if their workloads are primarily we call it cattle versus pets. That's something you'll hear this week a lot: cattle versus pets. I don't want to be insensitive and use cattle, but let's say chickens versus pets. You've got livestock. So when you create workloads, they get created and they can horizontally scale. Like web, you can put behind a load balancer and scale it horizontally, and nobody knows the difference, right? One acts up, you shoot it in the head, it goes down, you bring another one up, nobody's the wiser. If you have applications like WebSphere, WebLogic, things that are these types of persistent applications that know about each other and care about their partners, those are not cloud native type good apps for OpenStack. Now that being said, OpenStack is plenty fine as a virtualization platform. It has some of the tools now that VMware has, and storage DRS, VM DRS, all of that stuff can be kind of engineered into it. But it's more, you say, when would it be a time for them to change? Well, one, when they run out of money paying VMware. If there's any VMware people in here, sorry. But when they get done paying VMware all the high licensing fees, or when they want to save some money, taking some of those workloads that can move over, that would be a good start for them. And then these cloud native workloads that they can move over that are not pets. They're not servers that if they go down, you want to log into them and bring them back up. They're Apache, LAMP stack type stuff. VNFs, the virtualized network functions that they're making cloud native now. These are all things you want to put on an OpenStack stack and get them off of a more expensive stack.
Just a typical situation. Existing public cloud provider just has the cloud implemented on the not OpenStack. And is it possible to migrate OpenStack? And assuming we'll just use the same provider
Right. So migrate from VMware into OpenStack?
No, just yet. For example, we have just yet it's infrastructure provider like a VMware.
VMware, okay.
Provide the
Right. Like, okay. Okay. So I'm not sure what you're migrating. You have a public provider? Customer VMs, moving them from the public provider to your local? That's easy. I mean, that would be, I wouldn't say it's easy. I mean, it's everything in reason, but you could basically make snapshots of their images that are running on this provider and then bring them over and put them on your private cloud. In the state, it's called a Nova snapshot. You make a snapshot of it and bring it over. Now, there are ways to do it a little bit more gracefully. There's a project out there called Cloud Ferry that allows you to go from OpenStack to OpenStack. But there's no way to live migrate them, like, move them from one cloud to the other. But Cloud Ferry would be the closest thing. But if they can take some outage, create an image and move it over, shut it down, replicate the storage, bring it up. It's as easy as that. It's from OpenStack to OpenStack is easy. Even VMware to OpenStack is easy. So, well, thank you. Somebody have another question? I'll take one more. Does who does? Seems like it, doesn't it? Red Hat doesn't have a certification. Red Hat does have a certification. Mirantis used to have a certification. I think they still do. And the foundation has a certification, the Certified OpenStack Administrator certification. Those are the three that I'm aware of. Now, there are some other ones out there that are not as popular, but I would have to say out of popularity, Red Hat first, Mirantis, and then the COA exam from the foundation is kind of a no-brainer. You want to get that because that's actually from the foundation itself. And the COA exam was put together by all of the different distributions. They contributed to it to make this one exam. So it shows proficiency. All right. All right. Well, thank you guys for staying around. And thank you. Thank you. Thank you.